Hi guys, welcome. And today in this tutorial we will take a look at the timers with the PPI module. Today what we are going to do is we will connect the timer event with the event endpoint of Programmable Peripheral Interconnect, and we will route this to the task endpoint which is connected with the GPIOTE task. So this all procedure does not involve the CPU. So it's really efficient, and let's see how we can do this. First of all, we are going to create a new project. So go into my computer and then go in the C directory. Here we have extracted our nRF SDK, and then I'm going to go in the examples. Here we'll go in the peripherals and we will copy the GPIOTE this time again, and then we will paste it in our projects, and let's name it as timers PPI GPIOTE. So open this folder and go in the PCA10040 because we are using nRF5 to 832. Open this folder, blank folder, and then go in the Sagar Embedded Studio folder, and here we have this EM project file. Open this, and we have some code. I'm just going to delete this. Just make sure you have these libraries, and okay, we are good to go. So we are going to create a timer, and as we have seen in the previous tutorial how we can do this. After creating the timer, we will create a task for the GPIO toggle, and that we are going to connect it with the PPI. First of all, I'm going to create the timer. So we are going to create a GPIOTE task and also the timer. So let's create a simple function which contains everything. Now in this function we have to initialize the GPIOTE and also the timer, and also the PPI module. So we will initialize everything here. So let's start it. First of all, we are going to initialize the PPI. For that, we need two variables to store the address for task and event. And we also have to create the PPI channel for that. And we also need to create an error code variable. So for that, this time we are going to use the RET code T. Basically this is provided by the SDK, so let's use it. Let's configure the GPIOTE. So we are going to define the output pin. So in this case, and pass in the configuration. Now we need event and task address. For that we need to initialize the PPI channel. For doing that, let's initialize the GPIOTE and then initialize the PPI. And also we need to initialize the PPI. We have initialized the channel, we have initialized the PPI, and also let's allocate the channel. Okay, now we are ready for passing the addresses. So first of all, we will save the addresses for the task and the timer event, and to do that we need the timer to be initialized. So let's initialize the timer now. We need a handler for the timer because we cannot pass it the null value, so we need the timer handler here. So right now we have the timer handler, and we will pass it to the function that we are going to use to initialize it. Now we need to pass the configuration and the interrupt handler routine. Now we need to configure the timer with the tick value. Okay, now the timer is initialized and it started. So now we are going to get the address for the timer and the GPIOTE and then assign it to the PPI channel. So now we need to get the address for the task. We are going to pass these addresses to the PPI channel. Once this is assigned, we need to enable the PPI channel, and we also need to enable the GPIOTE task. Now we need to enable the GPIOTE task. Okay, now everything is done. We have initialized the timer and the PPI and everything, and right now what we need to do is we just need to call this function start timers LEDs. And it's going to do everything. And the last thing here, we need to enable the timers. We need to start off the timer, so we will enable it. And everything is finished. We have created a timer, and it's going to generate an event, and we are not going to work in the interrupt handler because we have taken this address and we have connected it with the event endpoint of the Programmable Peripheral Interconnect, and the task endpoint is connected with the GPIOTE. So whenever an interrupt is generated by the timer, it's going to route it to the task, and this task is automatically going to be executed without the need of the processor. So let's see. We will build this code. Okay, so there was a little mistake here. I accidentally put the void here, so we need to put the static here. Okay guys, once the project is built, just go make sure your device is connected with the USB, and go on the target, click on the connect, and then erase all, and then download the code. And once the code is downloaded, here you can see the LED is blinking, and this time this LED is blinking without the help of the processor. And what's happening here is we have connected the timer event with the GPIOTE task. So every 500 milliseconds the timer is generating an interrupt, but it's not going into this interrupt handler. Rather, this interrupt is just being passed as an event to the GPIOTE task via a PPI module. So right now this PPI module is helping in driving the LED without the help of the processor. So it's really useful and efficient. So hope so you have learned something new today. Thank you very much for watching, and please be sure to subscribe to my channel and hit the like button if you like this video. Thank you very much for watching. See you in the next video.